Hi, welcome to this chapter on digital realities in the Programmer's Field Guide. I'm Andrew. Learning to program is really the foundation of all of the careers in computing. And so understanding this will really help set you up for success in whichever career you're looking at progressing in the area of computing. Now, programming, I think, is a really interesting thing to learn. And one of the biggest challenges that you're going to face is the fact that programming is the hardest when you're getting started. The first few bits of getting started with programming are the hardest. And once you've got over those, things start to get easier once you understand the basic mechanics of how it's working. So the next part of our check is actually going to be the trickiest. You'll have support as you go through that, but work through the material very carefully and take your time as you go through this part of the journey. One of the biggest challenges is that you can't see your program. And so having a way of understanding what you're doing can be tricky. You need a way of picturing what's going on to help make it easier to understand. Picturing what's happening will help you unlock the ideas. They'll give you the concepts. They'll help you connect the concepts with what you're seeing happening. Because this is a very abstract thing you're going to be embarking on. You have to be able to imagine your program in your head, imagine what's happening, and connect that to the code on the screen, or the other way around as well. So looking at the code and using that to imagine what is actually happening. As you're creating, you're imagining it and writing it in code. And then when you're reading the code and imagining what's happening. So you have to be able to picture these things. And so we needed a way of thinking about how to picture them. We think the idea of thinking about programs as digital realities can really help you picture and get a sense of what's going on inside the computer. That's the focus of this chapter. Let's have a look at this. We'll step through the idea that computers are unintelligent. We'll look at the idea of layers and abstraction, and then we'll look at using those layers of abstraction to build digital realities. And what do I mean by a digital reality here? The key at the start of programming is to remember the computer is unintelligent. There is no intelligence in the computer. Even artificial intelligence isn't really intelligent. What's happening is the computer is executing things in a mechanical fashion. It's following instructions, and each of those instructions is getting the computer to do a certain mechanical action. It does those instructions incredibly quickly so that we can get it to do things that look really amazing, that look really intelligent. But that intelligence is not coming from the computer hardware itself. The intelligence comes from the instructions that are manipulating that hardware, the instructions that are getting it to do things. So it's the instructions where the intelligence are. And as programmers, we are the ones who create those instructions. In terms of the computer itself, we can think about them in what we call layers of abstraction. Programming is all about us conceptualizing what's happening. So we have to sort of make our own reality. So let's see how this works. If we think about it at the bottom level here, at the bottom down here, we can think of the computer as being a machine where we have current flowing through circuits. And these circuits are made up of transistors, millions and millions of transistors, and the transistors are enabling the current to flow in different directions depending on current flowing in different places in the machine. Yeah. So in one place we've got the instructions, and that is coming through as a current. That current then flows to other parts of the chip, which then do different things in order to influence something. So maybe it directs some current to change the color of a pixel on your display so that that changes to one color, and something else is getting it in a different place on the screen to change to a different color. All of that is happening very quickly through the machine. Now, I almost never think about my computer at that level of reality. That's actually what's happening. It's all just current flowing through digital circuits. But I don't care about that. I build a reality on top of that. Now, you might care about that when you get your soldering iron out and you're connecting some things to a circuit. But when you're working in programming, we're working at a higher level of abstraction. All of these things still exist, and we need to move between these different times. Now within the computer, we can then use this current to create an abstraction of binary. So we can now say computers work with ones and zeros. That's an abstraction. It's not actually true. It's all currents flowing through circuits, but we make it true by building a reality, an idea, a thought in our mind that a computer is all about ones and zeros. I'm sure you've heard that. And that's a really great abstraction, a very low level abstraction, slightly above the hardware. Now those ones and zeros we can then use to start to abstract into data, where we could say these ones and zeros will interpret in this way, and then that means it's a number, and these ones are interpreted that way, so it's text, and this is an image, and that's something else. It's still just current flowing through a circuit, but we are now thinking about things as data. We can also think of things as instructions, so I can say here is this instruction, here's a different instruction, and each of those are just data, ones and zeros, which are actually current flowing through a circuit. So these are, notice how at each level the reality can exist and it abstracts away details from the lower level. Once we've got data and instructions, we can start to organize our data, and then we can start to build functional entities. And on top of that, we can build our programs. So our programs are a layer of abstraction that we are building on top of this digital machine. So if we're able to build these layers of abstraction, then the digital realities are the programs that are sitting at the top of that reality. When we create these programs, we can now start to pretend that those things actually exist. And this is a really interesting thing to think about. Now, one of the ways we could think about it, let's think about your bank account. You probably have a bank account with a bank. You probably have an app on your phone or something where you can check your balance. Now, if you get into that, you can see it says you have a balance of X dollars in your account. But are they actually dollars? They're not really, are they? They are data stored within the bank's computer system. So that bank's computer system is a digital reality. Now, the great thing is our lives are a mix of our reality and these digital realities. They are so connected that we often don't think about the digital reality. When you're working with your bank account, you see money. You can say, yes, I've got that money. And we can actually get the digital reality to affect our reality. I can go to a machine in the wall, I can put a card in, can type some values, that's going to get some current to flow through some circuits. It's going to go to a machine, a motor, the motor's going to spin, and money's going to come out. And what's going to happen is value in my digital reality will be reduced, so I'll have less money in my digital reality, and in my physical reality, I will have a note in my hand. So this is the connection of digital realities and our reality. So let's think about another example. We could think of something like a Word or a word processing document. When I'm in Word, I'm thinking about paragraphs and images and pages. There are no pages or paragraphs or images in the computer. It's all current flowing through a circuit. So how did these things appear? We created a digital reality that we now connect very naturally with. As you're programming, you will be creating this reality. When you create a program, it is about imagining what you want in the computer. What is the reality you want? And how are you going to create it? You then use code to create that reality. All of those realities exist because we have dreamt them up. We have imagined them into existence in the computer. So can picturing programs as digital realities help you get started with programming? Getting started with programming really is the hardest part. Okay, so stick with it. Get yourself a tutor. Work with them. Work with others who are learning how to program. And step through these things. Getting started is the hardest part, and having a way of picturing what you're doing is really important. We're suggesting picturing programs as a digital reality. You're always thinking about how do the instructions that I put in my code let me create things in that reality? How do the instructions in my code let me do things in that reality? And we are then using that code to shape the realities that we want to create. It'll take time for us to build up to those, building really sophisticated and complex realities, but we can start with simple things, we can build up, and we can understand how they work. That's the key. Learning is about shaping these realities. That's what programming is, and it's a super exciting field to be in. You get to create these things that don't exist, and we can then connect them to millions of people using networking. We can do amazing things where we interact with the real world through hardware, through displays. There's so much that we can do. Everything is influenced by computing now. Enjoy the journey.